China's standard support scheme. During the service life of mines and tunnels, the initial lining bears no load or only limited loads. Therefore, in China, long-term performance typically focuses only on the final lining, not the initial lining. However, common accidents and disasters during tunnel and mine construction are often caused by delays in secondary lining construction and insufficient initial lining support performance, especially the inadequate toughness and crack resistance of the initial lining shotcrete. China's commonly used tunnel support methods include initial lining shotcrete, followed by geotextile waterproof membrane or waterproof board, steel mesh for secondary lining, and then cast-in-place concrete. With such a complex construction scheme, the secondary lining construction schedule is inevitably delayed. Meanwhile, using plain concrete for the initial lining means the toughness and crack resistance of the concrete is inevitably insufficient.
The Internationally Common Support Scheme. The Internationally Common Support Method uses ultrafine cement advanced grouting, initial lining with fiber-reinforced waterproof shotcrete, then spray-applied waterproof membrane, and secondary lining with fiber-reinforced waterproof shotcrete. Using vehicle-mounted wet-mix shotcrete machines, spraying 3 times completes the construction. The tunnel primarily uses rock bolts and steel arches, eliminating steel mesh. The overall project cost can be reduced by 30%, and construction speed can be doubled. The International Support Scheme has 4 major advantages. First, the primary lining fiber concrete has very high toughness and crack resistance. Second, secondary lining construction is very timely. The adhesion of shotcrete to tunnel walls is much tighter than cast-in-place concrete, especially in narrow areas such as edges and corners. The elimination of steel mesh greatly saves steel materials, steel construction, and the costs of transporting and storing steel in tunnels. Since steel corrosion is the main maintenance issue in tunnels and mines, the durability of concrete is often limited by the corrosion rate of steel. Steel mesh corrosion can cause catastrophic consequences. Therefore, internationally, there is skepticism about the extensive use of steel in tunnels and mines.
Standards for the International Support Scheme. International toughness testing of fiber concrete follows the American standard ASTM C1550 round panel test. The test yields the RDP energy absorption value from the round panel test. Based on international design guidelines for tunnels and mines, combining rock mass quality grades and RDP energy absorption values from round panel tests, the spacing, length of rock bolts, and thickness of shotcrete are designed. Internationally, over 5,000 kilometers of tunnels use structural synthetic fiber reinforced shotcrete. 90% of mines in Australia use structural synthetic fiber shotcrete for support.
The El Regajal Tunnel in Spain has complex geology with high salt content clay. The tunnel support uses 300 millimeters thick structural synthetic fiber shotcrete. The Hindhead Tunnel in the UK, at its deepest point, 65 meters below ground, is 1.83 kilometers long, 9.5 meters wide, and 5 meters high. The tunnel uses 6 kilograms per cubic meter of structural synthetic fiber shotcrete for support. The Devil's Slide Tunnel in California, USA. 2 tunnels were excavated through San Pedro Mountain with a total length of 1.25 kilometers, 9 meters wide, and 4.75 meters high. The tunnels cross 3 rock formations. Based on the rock formation orientation, the primary lining uses fiber shotcrete, rock bolts, lattice girders, spiling, and cement-grouted steel pipes. The secondary lining uses fiber shotcrete. The Caldecott Fourth Bore Project in California, USA, involved excavating a tunnel through rock formations. The tunnel is 0.9 kilometers long, 15 meters wide, and 11 to 12 meters high. The tunnel passes through 4 major inactive fault zones, with sections of solid rock and extensive areas of fractured rock. In the main support zones, fiber shotcrete thickness is 200 to 300 millimeters. In surface sealing areas, fiber shotcrete thickness is 50 to 100 millimeters. The Mount Ovit Tunnel in Turkey is 14.7 kilometers long and is the world's 6th longest highway tunnel. Due to severe winter weather in the Black Sea region that would halt construction, work needed to be completed before winter arrived. Using structural synthetic fiber that can be directly mixed with concrete, eliminating the need for steel mesh installation, construction progress was significantly improved. Excavation speed increased from 7 meters per day to 9 meters per day, a 25% improvement. The Tomei-Meishin Expressway in Japan passes through extensive mountainous terrain, requiring the excavation of 167 tunnels, totaling 224 kilometers. All tunnels use structural synthetic fiber reinforced shotcrete for primary lining. The E18 highway in Norway passes through 7 tunnels, with a total length of 5.7 kilometers. Due to Norway's temperate maritime climate with high humidity, All tunnels use structural synthetic fiber-reinforced shotcrete for primary lining to prevent steel corrosion.
Narragansett Bay in Rhode Island, USA, established an underground tunnel wastewater treatment facility. This facility can collect 240 million liters of sewage and send it to deeper underground tunnels for storage and treatment. The rock tunnel is 6.2 kilometers long, with a diameter of 5 meters.